Welcome to another episode of the Concrete Logic Podcast, and I have Dan McCoy back. Shot. Dan, you're back.
Unbelievable.
Yeah. Dan with RL McCoy is back with us, and today we're going to see, I don't know, how two concrete guys can talk about nuclear power. We'll see how much trouble we can get ourselves in. With that, again, this is a value for value podcast. So there's three things you can do to help out. So I provide you value by providing this podcast. And if you think it is valuable, you provide a value back. And there's three ways you can do that. One, please share the podcast with other people like us. There's more people out there like us, right, Dan?
Oh, we want to hide our enthusiasm for concrete. Why still? They know we geek out on this stuff.
Oh, yeah.
Help your man out if you're a woman listening to this and you're working in a professional concrete organization. You know that you've got a special man in your life that would rather listen to this than watch football.
Oh, yeah. Yeah, that's a good idea. I like that idea. The second way, so the first way is sharing. The second way is you can go to the concretelogicpodcast.com website and you can reach out to me a couple ways. You can there's a contact button on there. That'll email me, or you can hit the little microphone if you're feeling like you want to leave a voicemail. And I'm just looking for topic ideas or guest ideas. Most of the folks that come on this show are ideas from listeners or past guests, including Dan himself. Mr. Belkowitz or Dr. Belkowitz is our connection. So that's how Dan and I connected. Thank you, Dr. Belkowitz. Appreciate it. And then the third way is a donation. Running a podcast does cost money. It's not a free thing. We got software and hardware and things like that it takes to headphones, microphones, these sort of things. It sounds like we're professional. We're not professional, but we want to sound like we are. So if you want to go to concretelogicpodcast.com, hit the donate button, and you can give any amount, So whatever you're feeling, you're willing to donate to the show, and every amount is appreciated. All right, Dan, let's talk about nuclear power. You've mentioned it a couple times. You're a big fan. I'm a fan of it. There's saying something is getting pushback would be saying very little about the feelings out there about nuclear power. And I think it's just because there's been namely two or three major disasters that have happened, and the way those things were covered and the information that was provided to the public about those events has really morphed our minds about what nuclear power is and how dangerous it is and things like that. But Dan, I'll let you start and I'll just jump in where I can.
Oh, do more than jump in. I was hoping this was just going to be a fun discussion about two nuclear freaks, but it ties into concrete. For those of you that are like, I don't want to talk about nuclear power, I want to talk about concrete. It ties in. One of the greatest and most abundant sources of supplementary cementitious materials is fly ash. And fly ash does a lot of great things for concrete. In significant quantities, it reduces alkali silica reaction. It is a cheaper alternative to cement. It's a byproduct. So it's a usable byproduct that we can use. But in the green movement, as we're seeing, where you get fly ash from is from your coal plants, your coal fire furnace burning. And it is the reason it's used is it's incredibly cheap. It's incredibly cheap. It's incredibly inefficient in terms of coal usage. But compared to the other things you can burn, coal is very good. So if you versus say wood, burning timber to produce. But when we talk about electricity in the grid, just to put everybody on the same page here, all you're doing is taking the age old fact. It's really old technology. You just need to spin a piece of metal around a magnet and you create electrical current. So how do we create that continual spin? And best way to do it thus far, or we would have created something else, is to create a fluid that pushes this turbine around and around. You see it in hydroelectric dams where they use the natural head pressure of the water. As they release that water, it comes through, it spins a turbine around, which spins this piece of metal around a magnet, and boom, you get electricity. So another way to spin it is to almost what everyone uses in power generation is a basic steam. You use the differentials in pressure between steam and the open atmosphere. And as that steam is released, it produces that spinning motion through the turbine and it creates electricity. Then that's when all the power separates on that side when it comes to generation. So you can use coal fire plants. A lot of those are now being transitioned into natural gas, which is a lot cleaner, or clean coal technology, but natural gas. Another one that's out there is a natural gas plus hydrogen combination, but think about it. Everybody just think about it. It's a way to basically turn water into steam. And by far, if you're looking for clean, by far the most efficient is nuclear, bar none. It is the most efficient because if you look at it as every day, a coal plant requires about an entire train load of coal, whereas a nuclear reactor could take about a half of a single car from that train load, a single car, and run on that uranium for a year. In terms of efficiency, that's basically what we're doing. You're right, Seth. It's gotten so much blowback, but I think what we forget is power generation by steam has been around for millennia. Really, they've been using it to do maybe not make electricity, but they've been using it as an engine or as a motive of getting work done for that long. And it wasn't until Einstein's miracle year in 1905 that somebody said, "Hey, we can convert this into energy. We just have to hit it hard enough." In simpler terms, when you take a look at the forces of nature as they get stronger and stronger, you've got the force of gravity in the universe, and then you've got electromagnetism, and then you've got a weak nuclear force and strong nuclear force. And if you're able to separate atoms, you're talking about a massive amount of energy released. And that's the power of nuclear energy. It took another 30 years before Enrico Fermi decided, I think there's something here, put a massive amount of uranium. And people should know that naturally existing uranium, 238, that is the abundant amount of uranium. And where is uranium created? It's in huge, massive supernovas. The bigger the supernova, the heavier the element gets. And it creates a little bit of this uranium, this really heavy metal, this uranium-238. And then as it lands on Earth and it exists in nature, there are a few little atoms in that big chunk of uranium-238 that are uranium-235. And it's a very small percentage, something like 0.7% of this big pile of uranium-238 has uranium-235, which is the fissile material that we really like because it's easy to separate from when you shoot a neutron. And so one of the great benefits of nuclear energy is the fact that we're continuing our advances. And you brought up the three scenarios. Let's just talk about them. We've got 3 Mile Island, which happens. Now we're taking out nuclear accidents that happened previously to that. But if you take total death toll and total environmental statistics from all of them, I think the only one that's really cleaner so far maybe is hydro as far as impact to humans, not so much on the environment, what you find. But if we look at those accidents that happened in the early days, and usually they were related to the Manhattan Project.
I would just pause there for a second. I would say the hydroelectric impacts people. Actually, I've read things where it impacts as far as negatively impacting people. Hydroelectricity has impacted more people than nuclear power. Recently, it was Ukraine that had or am I messing that up? Where was the dam that failed?
Yeah, they failed that dam, which was it's one of the things that in military strategy that you always go for: communication, and then the infrastructure, especially power generation. If you knock out the enemy's ability to communicate and then produce power to fix communications, you've effectively made them dumb and blind. But yeah, you're 100% right. You're capturing, nothing's free, folks. So all this energy that you get, even if it's hydroelectric, you're taking that natural, on what we call hydrologic terms, that natural head, there's potential energy there. That's a lot of potential.
Yeah.
You get it when you spill a glass of water. You spill a glass of water, you think you make a mess. Open up the hole in an earth dam that has about a couple million gallons is even right word. These reservoirs are enormous,
Mhm.
but that is a lot of existing pressure head and a lot of flow coming.
Yeah.
Um,
And it
so
takes up a lot of land
it takes up
area
a lot of
too.
land, takes
Yeah.
up a lot of planning and a lot of resources. The Three Gorges Dam in China is one that they evacuated, not evacuated, the domain is the wrong. They displaced, they displaced a lot of people to create the reservoir that powers the hydro.
Yeah. And the environmental impact to just nature and animals and all that other stuff, related stuff too. I think people don't consider that as well with hydroelectric.
No, and yeah, that is a big one. I think, and there's probably people out there saying, "What about wind and solar?" Hey, I like wind and solar. I just know that the sun isn't always shining and the wind isn't always blowing, or vice versa. You have your main load, your base load. That's the term they use in the grid. You have your base load. That's the power plant that makes all the power, not all the power, but that's your base load power. And then everything else comes from that, the supplemental energies of wind and solar. And one of the biggest problems they've had, I read a book. Oh, I should read a book about the grid. Oh, and I wish I could give the author credit. Dang it. But one of the biggest problems they had with wind was they had a windstorm coming through a valley in the upper Northwest. And they already had baseload power on, but it takes a while to shut down baseload power. They actually had a problem with the grid creating too much electricity that couldn't be used. And it's the inability to control things like that that I think could get us into trouble, because all you need is to take several sections of that grid or the substations out, and you've got a lot of problems for a lot of people real quick.
Yep.
People realize that if you're sitting in a room right now, if you're driving down the road and you're looking at lights, you have to realize that at the speed of light, that light photon that just interacted with your eye was literally made in a power plant less than a second. So you have to realize how fast the speed of electricity is and how delicate that is if it's interrupted. That's one of the things they teach us in school when you're going for civil engineering. I'm kind of braggadocious, but it is true. The difference between a third world country and a first world country is civil engineering. If you don't have clean power to start with, it doesn't even have to be clean in a third world country, but if you don't have power, you don't have things for water filtration or even getting water or treating sewage, septic, and then that goes on to construction and building infrastructure or surface transportation. If you don't start off with those basic things and that basic freedom to have eligibility to tap into that, you're still going to be a third world country.
Yeah. As energy goes, your society goes. China and India know that right now. That's why they're building all the coal plants in the world that
They're
they can,
building everything.
and
They're
that's
building
and that
coal. They're building natural gas.
yeah,
They're building reactors.
yeah.
And
And that's where all of our coal's going right now, is over there.
I wish we would be doing. Like I think Vogtle 3 just came online a year ago, and that's down in
Georgia. Yeah.
boy, what a great project, but that's a full blown reactor.
Yeah.
So I guess I would want to know, what are the normal things that people tell us about nuclear energy that they're scared of? I
You want
think,
me to tell you? Because I know. I
yeah,
get
go,
I
I want to answer those
yeah.
right.
So folks that subscribe to the Concrete Logic newsletter will know that I write about things that I read about nuclear power and energy. And so when I do that, I do get responses about that they either agree or strongly disagree. The issues that I've seen or I've been emailed about is the waste. What do you do with the waste?
Mhm.
And then, of course, they talk about all the people that in people's mind, there's been a lot of people killed by nuclear power. So you started talking about it, but oh, geez, those are the two big things that I hear is waste. What do you do with the waste? What about all the people that have been killed by nuclear energy accidents?
See, that's exactly usually what you hear
Yeah.
from people. So if we have, I think
So the last one
Oh,
that folks have talked about, the last accident, like, I guess we could start with the accidents, is the Fukushima
yeah.
accident from the tsunami. What's interesting is I think I think everyone's on it finally got to the point where everyone agrees that only one person was killed,
Mhm.
in that disaster. And what's interesting is the latest thing that I read about it was about all the hoopla about how they're, releasing all the water from the, facility into the ocean, and people are all up in arms, like, "How are you doing? Why are they being allowed to do this, to release this water that was used in this facility, in this, nuclear reactor? Why are they able to release it in the water?" And if you actually read and dig into it, the water that they're releasing into the ocean, I think, am I saying it right? They're releasing it to the ocean, is actually cleaner than the water that you would get out of your faucet.
What?
That's the extreme efforts that the Japanese are taking to release this water. And it's not like they're dumping it all at once. They're trickling it out. It's
That's
true.
sad because they could dump it all at once, totally
Yeah.
unfiltered, and the ocean would eat it up so fast that you wouldn't have any idea what happened. The
Yep.
amount of dilution, I don't mean to be totally negative and mean, that's the difference. You think as a civilization that we're really big, 8 billion people, you could fit all of us in one county in California if we stood 5 feet. So we really don't have as big of an impact as I think that people think. Mother Earth will be here long after.
Yeah, we can get into that. I had that argument the other day with somebody. That's another podcast. But,
Yeah. So I'm interested in, okay, let's go right down I was fortunate enough last year, I took a tour of the Cook Nuclear Facility up in Michigan, which is just north of me. And as a nuclear freak, it was like, I was mind boggling. I just love this. And if you're a construction freak, go to a power plant. You want to see some big industrial stuff. Wow. Wow. Anything you've done, take it times 10. And that's the smallest component there. First of all, we talk about waste in the Yucca Mountain debate, which was in Nevada to store nuclear waste. That shut down. What the nuclear facilities do is they store this nuclear waste on site. And I would encourage you to go to Google Earth, anybody listening, and go to a nuclear facility. And what you will see is where they store their nuclear waste. And what you're going to be surprised with is how incredibly small the amount of waste there is. This specific one at Cook that you can see on Google Maps, just south of the facility, there's what looks like a football field. And inside it are containment vessels inside this football field that are about 10 foot in diameter and about 20 foot. They look like little silos. And you can see that there's probably only a 20, maybe. Those two reactors have been online since the early 70s. And that's the total amount of waste produced since the early 1970s. That's total.
oh, man.
Everything. Every bit of waste that you see is right there. And you look at it and it's almost, you look at it and you think, pretty insignificant. And that's the total amount of waste. And it's set there to cool off the contaminated materials. If you take a look at the really dangerous materials that are highly radioactive, total amount ever made by man wouldn't even fill half of a swimming pool. I realize I'm making light of this, but I just feel like when people hear this or hear about nuclear waste, they think it's just this huge amount belched out all the time. And it's not. You're producing steam and you're producing this electricity naturally free from deleterious materials released into the air. All of it is contained within the reactor vessel. And then when the fuel rods are spent, they take the fuel rods and then they cool them in a pool for several years. And then once they're done, they put them in storage containers after they've cooled. They continue to air cool them. But the dangerous materials are taken out of them. The severely dangerous materials are taken out of them. And then the nuclear waste from the fuel rods that basically don't have any power left in them anymore. We can get into future reactor designs. But most of what we're doing now is generation 1 and generation 2 reactor designs. These are designs from the 1950s and 60s, folks.
Mm.
Enrico Fermi made the first reactor, which was a research reactor in Chicago in 1942. When you consider that most of these designs, even Fukushima in the West, let's keep it real. In the West, these generation 1 and 2 designs are from the 50s and 60s. There's nuclear engineers out there and physicists that have come up with way better ways to split an atom than what was done in the 1950s and 60s. But every time it's brought up, they're poo-pooed about the dangers. But you go to generation 3 or generation 4 type reactors, we're talking about then taking that nuclear waste and actually reusing it in the reactor as an additional fuel to get more energy out. And there's passively safe reactors. There's now reactor designs theorize that you don't have to shut down because you use nuclear pellets. You create these pellets that come in through a funnel, and then once the energy is drained, the uranium is drained out of that pellet, it simply drops out and goes to store it. You don't have to shut down an entire reactor of fission fuel rod.
Oh,
There
that's
are
cool.
so many advanced designs. I'm most excited about, there's a company called NuScale.
Yeah.
Have you heard of NuScale?
If you're following nuclear energy news, it's what was it last fall that everybody was saying because they shut down one of their projects that nuclear power's over or something. It's some hyperbole like that. I can't remember.
I think the SMRs, if people look into it, the SMR, the small modular reactors, that will be the wave of the future. I really like the way they think out that plan about creating a modular reactor that's self-contained. But a municipality or local utility could buy it, and then you stack them up in banks, almost like a battery. And then if one needs maintenance, you can always have 9 others online, and you're creating a total amount. If you do 12 of them, about 1,000 megawatts, if you've got them online.
Yeah, what's really interesting in the industry that's talking about this stuff right now is data centers. So right now the problem with data centers is getting power to them.
They use a lot of electricity. Yeah.
Yeah, they usually, yeah, definitely. So they're talking about in the future having these small module reactors is using these on a data center facilities, and they'll be able to, like you were saying, Dan, is you can start with one and then add to them as you need them
Yeah.
versus the thing that's slowing data center construction down right now is getting the power there first because that's what needs to be there first, right? They use so
Yeah.
much energy. Microsoft, I think, yeah, it was Microsoft. They posted a job opening for nuclear energy or whatever they call it. Yeah, I forgot what that was called. And that went all over, at least in my circle of what I follow. It was all blasted all over the place. And everybody's, oh, look, Microsoft's into it. So I think we're seeing some maybe fringes of the industry lean into nuclear power. We just got to figure out what's the best way to do that because you're not going to power data centers with a wind turbine or solar panels. And we truly don't know I don't think we truly know the negative consequences with the wind turbines and the solar panels yet. I don't like those two sources of energy because I'm all into efficiency and those things aren't efficient to me. They take up too much mass to do those things, and I think they're ugly. I don't wanna look at them. I don't wanna see them.
What's a really good reason?
Yeah.
Superficial, but it is if it becomes part of it. But on the other thing, what are we going to do with them when they're done?
Yeah.
Nuclear waste, like I said, everything that I've ever seen from two reactors from the 1970s fits inside a space that's half the size of a football field in cylindrical tubes that are 25 feet away from each other.
Yeah.
That's the total amount of waste. But you start talking about what's going on with solar panels and how we're going to recycle those. I don't know what we're going to be looking at.
Yeah, with, again, subscribers to the Concrete Logic newsletter will know I shared with them, and it's been some months, but down in Texas, there's a town that somebody talked them into doing this, some business or whatever that recycles the wind turbines it's just acres and acres of these wind turbines that are either broken or used or whatever, and they're supposed to recycle them, but they don't know how to recycle them, so they're just stacking up over there, and the town's going crazy. They're like, "We don't want this stuff in our town." So, yeah, yeah, to me, these things, like you said, though, there's trade-offs. There's not a perfect
Yeah.
answer. I'm not saying nuclear power plants are the most beautiful thing to look at either, but I think instead of investing the billions and billions of dollars that we're dumping into solar energy and wind power, I think that money is better spent on nuclear power. We could figure out how to address the things that people are most concerned about with nuclear power with that money, safety and waste management and things like that.
I look at, sometimes I get myself because I think about California. Um, and I think what a perfect place for reactors, right? They have a power shortage out there. Um, if you put reactors in, you place it next to a coastline, similar to Fukushima. I don't want to make anybody panic, but if they know the details behind Fukushima, every one of those errors has been accounted for and fixed in future design. And it was mainly the effect of an earth, an earthquake, a record-breaking earthquake with a record-breaking tsunami drowning out the backup diesel generators. That was basically the whole problem. That's been fixed in every reactor around the world. The backups that have been gone into that. But if you look at a state like California that constantly has grid problems, constantly has outages and brownouts, you could solve a lot of problems with a reactor, not only in power, but they also have a problem with water. One of the greatest things that you can do with the additional power that you make from a reactor is run a desalination.
Right.
You can literally make drinking water out of the ocean. They have this, there's always freshwater shortages out there, and the South blames the North and the agricultural district for using all the fresh water, but you need food. Yeah. You need farmers. I'm pretty sure, I might be making a mistake here, but I'm pretty sure California might be, it's at least in the top 5, if not the top 1 or 2 for agricultural and production in the United States. I think a lot of people find that surprising. There's a huge farming community there, and it does take water to grow things. Um, but you hear these things about, we can't have a desalinization, and that'll take 20 years. I heard that 20 years ago. And if you would have started then, you would have had it now. You think about those things, and it takes power to run those things. But you also need, if you're running, and reactors are most efficient when they're running at high output. So now you've got, in the nighttime when maybe you're not using all the industry, you don't settle the reactor down. You use that baseload power plus whatever it's making to run your desalinization. Or in more rural areas without salt water in the country, you use it for hydrogen generation, and you produce hydrogen gas, which is another incredibly useful fuel that a lot of people are afraid of for some reason. I think since the Hindenburg disaster, they were really afraid of it, but anything that burns can create energy. There's that potential chemical energy involved. And I wish people would get past the stigma and really do the research and not believe everything they hear about the nuclear industry. We mentioned, right, 3 Mile Island, Chernobyl, and then we've got Fukushima. 3 Mile Island, that was a personnel error, a training error about a valve being stuck open when they didn't believe the computer said the valve was stuck open. It went into a meltdown scenario. The containment vessel trapped everything. This was a worst of a worst scenario, and it was all contained within the reactor vessel and then the house. That's like the worst you can get. And that's what happened in the United States. Chernobyl, Russian standards were a little bit different. The reason that RBMK reactor was so immense and huge to create 1,200 or 15, actually that was a 1,600 megawatt reactor. They used lower enriched uranium, right? Because it takes energy to enrich the uranium to a point where you get a fissile material out of it. We look at ours as between, I think, what's fuel grade. Somebody's out there screaming at me, but it's 10%. And the Russians use like 3%. Right? It takes that much more volume to create the same amount of energy. And they didn't put as much energy in enriching that. More than likely, they kept enriching it to make weapons. But the reactor itself then was simply, if you ever look at pictures, tell somebody to go look at pictures of Chernobyl. There's no concrete secondary containment. It's in an open building that you would see on your grandpa's farm if he just put a new pole building up. That's what was there. It's surrounding the reactor.
Wow.
You don't have a containment vessel, a reactor containment vessel, and then everything else that went wrong with it. It was a graphite moderated reactor, which is great for slowing things down and making that reaction pretty efficient. But when it's run away and you produce all those toxic bad things that slow a reactor down and catch them up real quick. That's what you get, is an immense amount of power incredibly quickly. Not so much an explosion, but I know there was an explosion related to the hydrogen that came from it. And the same thing at Fukushima, but then again, it was designed to do that. You have a hydrogen leak and it's meant to belch that out. And if it catches fire, it still doesn't reach the containment that you see around these reactors. And it's interesting that you say that about Fukushima, because there was a college study that was done where they wore their dosimeters from the moment they got to the airport, flew over to Japan, toured the site, and then flew back. Everybody looked at the data from the dosimeters and they realized the highest exposure to radiation they had was when they were at 35,000 feet in the airplane.
Yeah.
You can't make this stuff up.
Nope.
And that was standing at ground zero of Fukushima. So there's some misnomers about it that I don't really like. And I feel like if we spent more time working a problem, we would get to a better solution. Fusion energy's out there now to make it work. When people that poo-poo that idea, I think all you need to realize is the sun's a pretty big thing. I think this might be controversial, but I believe that the burning orb in the sky has a little bit to do with global temperatures. When you consider that in that nice fusion reactor that we call a sun, it makes more power in a second than the human race has ever used. And I realize that's really attractive to the solar power folks. But you realize the broad band of energy that we get 8 minutes away from it is just light energy, the truly most inefficient form of the energy that it creates. You realize how big of a deal that a fusion reactor is. And they've created it in a lab at JPL, and it matches, surprisingly enough, it matches the first that Fermi got with a fission reactor. Efficiencies are incredibly low. And then they get better and better over time. We're talking about efficiencies that are in the single digits up to 13 or 14%. And even now, the greatest power plants that we make, the most efficient that we can get, they're still at only 30 or 35%. Efficiency is one of those things that will just bite you in the end. And people say, how's that? It's everything that goes into making. How much, even when we ran the Manhattan Project, I think we used like 80% of our nation's electricity to be able to build those, or to be able to produce enough uranium-235 at the first bomb to be able to do that. I talk to people all the time. They don't know the difference between the two bombs and the difference between that and nuclear reactor. There's a hell of a difference. Totally different thing. We have a long, prolonged chain reaction that's continuous. Where in a bomb, you want a huge supercritical reaction, and you try to make it last as long as it can. But they're totally different. So you can't make a nuclear bomb out of nuclear fuel rods from a reactor. I guess you could, but a lot more energy than you want to put into it.
Yeah.
You could technically make a dirty bomb, but the security that I saw at the nuclear facilities that's placed not only by the private contractors, but by the Department of Energy, good luck. Try it, but there's no way. And then even if you got in to make a dirty bomb type scenario, there's so many fail safes. That it is to me, and it's been statistically proven, it is the safest form and the cleanest form of energy that we can make as of now. And just imagine if we just put a little bit of time and effort into it to do passively safe reactors, or use molten salt reactors, generation 3 or generation 4 reactors, and actually invested in those. And that's why I'm excited about the small modular reactors, because we can do it on a smaller scale. And then anything that we do, we can change faster and more rapid. We can expand that more rapid than we can, like, say, a Vodal, which is like a 15-year construction time and $22 billion.
Yeah.
A huge, massive reactor.
Yeah. Cause that's it.
It's kind of like, it's built already. It was designed 20 years ago, but that was using designs that were 20 years old. And you're looking at a 40-year life cycle for a plant, which now they can extend on. It's more than 40 years. But it's still an attractable option for utility companies. And believe it or not, the Department of Energy you can still go out and you can still apply for grants. And they do give a lot of money to these utilities and power producers for research on these reactors. But there is a large stopgap in what they approve because they're so dangerous. The nuclear regulator, the NRC, really gets involved with it. More so hoops to jump through than any other means of power. Just because the stigma that's created with radiation, and mainly probably the weapons usage.
Yeah.
But yeah. I just love talking about this stuff. I could go, if you want to go on stuff, I just love it.
Yeah,
The
I can
stuff,
tell.
well, it's just so fascinating in the stuff that we could do. And it's whether it's construction, whether it's power, whether it's anything, I like to immerse myself in it before making a brash decision making about it. I like to research and know as much as I can. And usually nobody knows everything. And that's the beauty of it. The more you talk about it, and the more you do it, the more you learn about it. And it makes you better along the way. Maybe you want to change some of the decisions that you made 20 minutes ago or 2 years ago. Nobody told you to do that.
Yeah.
That's the whole point of life, is to continually grow and empower yourself with the knowledge of what you need. So I hope people that are listening, if they didn't like, odds are if they listen to you, they probably like nuclear energy. But if they didn't like it, hopefully they thought about it and maybe got some fuel to think about for the future in conversations that they have with people that maybe don't like nuclear. But it's definitely one that everybody brings that up. But I say the United States Navy's got a pretty good track record with small modular reactors, and nobody seems to be worried about them too much.
Yeah.
People shoot things at them. So there's a little bit of evidence there that we're pretty safe.
Yeah, those guys know what they're doing.
Yeah. Yeah.
Yeah. All right. No, we'll pause there. Definitely something we need to revisit and talk about more. Yeah, as those SMRs progress. I know here in Virginia, the governor is pushing for some of that to happen here and trying to invest money into it. And I think it's just, if everybody that is, I guess, that understands the potential of nuclear energy just speaks positive of it and doesn't just ignore people's concerns and try to point them in the direction where they can read information about what is truly the history of nuclear power and how it's impacted us and all that. And as far as like you said, it's so heavily regulated now, it's got to be the safest thing to be. But yeah. So Dan, I'm going to share everybody's contact information so you can get some of the hate mail that I get about nuclear power. And
That's
then,
fun. That's
yeah,
I welcome it, because it's not so much that they hate it, they just don't understand it.
yeah, exactly.
And that's totally understandable to not understand. And it's very complex. And there's so much news out there about this, about everything we look. But you said it in the beginning, and I guess this will be the last thing I say, but I want everybody out there to think about what you said, where you get your news source. I would just like everyone to go back in their head right now and think about a news story, any news story that you thought about in the last week, year, whatever, that you had intimate knowledge of. There's got to be one out there, whether an accident happened next to your house or whether there was something going on at work that was reported that you know about. I guarantee if you look at that news story, you've watched it and you thought, well, that's not right. That's not the way it was. Just know that every news story has someone connected to it that's saying the same. Journalists don't have time to relive your experience and take your perspective on it, on that news story that you are into. Every news story to them is like that. All they can do is get a synopsis from it and take that advice. So I would just know that every news piece or news article that you hear, there's someone out there with very intimate knowledge of it that is going, not exactly. And I think that's probably the best mission that I can give people to do, is say, look at what media reports are. And it's not their fault. They're out there to sell advertising and get money, and they still have to bring you the news, but they're just not as knowledgeable about these subjects, individual subjects, as any one person is that's connected with others. And I think you'll find, we've all seen construction stories before, and they'll say something and you're like, no, it's not. That's not why that happened. We all know that, but you have to remember, we're experts in that field. But in someone else's line of work, they may be talking about something that you don't understand, but you just take their word for it because you don't understand it. There's somebody else that's intimately connected with that story or that industry that is looking at that going, that's like that.
Yeah.
You have to keep that open mind every time. And I'm not blaming journalism. I'm not a journalism hater. I'm just saying that if we have to write about something that we're unfamiliar with and we've got a deadline in the next 3 hours, we're probably not going to be 100% right about everything that we're going into it. We've covered facts. We've somewhat seen what's going on, but we're not intimate with the relationship that developed that story.
Yeah. I think that's very fair. All right, Dan, appreciate you coming back on the show. Everybody, until next time, let's keep it concrete.